I'm going to be going through the practice for 2.4, factoring polynomials. This is page 8 in the Algebra 2 packet and page 14 in the honors packet. I'm going to be referencing back to the previous page, page 13 or 7, which is the notes on this topic. So if you haven't watched the video or if you haven't taken the notes on this topic yet, I highly recommend that you do that because we're going to be referencing these notes pretty consistently as we go through this practice. So starting with the first one, again, when we're factoring, we're trying to undo distribution. So when we distribute, we kind of take this 2x and there's 2x plus 3, and we multiply each of them by x plus 5, one at a time. And we distribute again, and we combine it here, combining like terms. And so we're trying to undo this process, right? We're trying to undo this process of double distribution to get back to something that looks like this. So in order to do that, our first step, remember, because this is a complex process, we want to do it with the simplest expression possible, which means before we even get started, we want to pull out the greatest common factor, right? We want to pull out as much as we can from the outset so that we're dealing with the simplest expression possible when we start to factor. So to do that, we want to find the GCF. GCF of these three numbers, right, starting with the coefficients, 6, 9, and 27, is going to be 3. So to find the coefficient, or to find the expression we actually want to work with, and do 6x squared plus 9x minus 27, you want to divide each of these by the greatest common factor. Remember, the greatest common factor, that's the biggest number that goes evenly into each of these numbers. And so if we divide each of these by 3, we're going to get 2x squared plus 3x minus 9. And so this is going to be an easier kind of expression to factor than this. We just need to remember to put the GCF back out in front at the end. All right. So if you remember to do this, you need to start by splitting up the b term into two different terms. And to figure out what terms we need, we're going to use the magic x. So I guess actually, before we jump into that, let's label our coefficients. So a is 2, b is 3, c is 9, -9. And so we can see that for our magic x, we want to multiply a times c to get the top number. And so that's going to be -18. And then we want to put b as the bottom number. B is 3. Remember, b is 3, b is 3. So now we want two numbers that, and maybe I'll put 2 times -9. That's where we get 18, -18. So we want two numbers that multiply to -18 and add to 3. I'm going to go with 6 and -3. Feel free to, if you need to make a factor table for 18 and think about, go pairwise and see if they add up to 3 or subtract to 3, and then you can kind of adjust the signs accordingly. But it's also good to just build an intuition for this. All right, so now that we have the numbers in our magic cross, 6 and -3, we want to rewrite our original equation, not our original equation, but the one that we got after we factored out the GCF, expanding the b term into the two factor pairs we get in the magic x. So it's going to be 2x squared, and that's going to be plus 6x. Instead of writing a -3 there, I'm going to put plus a -3x. It's the same as saying subtract 3x, but I'm going to put plus a negative, just it's easier to keep track of our signs. And then I'm going to do -9 at the end. And just to make sure that it's clear, it's these two terms together, 6 plus -3, that gets us back to our b term in our original equation of +3. Now we want to put parentheses around the first two terms and the second two terms. We want to factor out the greatest common factor from each of those parentheses. So 2x squared plus 6x, well, that's going to be 2x. Right, the greatest common factor is 2x, and that needs to be x plus 3 in the parentheses to make sure that it multiplies correctly. Looking at the second one, we have negative 3x minus 9. What's our greatest common factor between those two? Well, it is negative 3. And to make sure we distribute correctly, we're going to put x plus 3 there. And make sure that you see that negative 3 times positive 3, that's going to give us the negative 9 that we're looking for. And then finally, we're going to combine these two terms, and we're going to get 2x minus 3 times x plus 3. Right, our first step when we're double distributing is to take the 2x times the x plus 3 and then negative 3 times the x plus 3. When we undo that, we kind of combine these two into this new parentheses. We're essentially factoring out this x plus 3 from both of these terms and putting it out in front. So you end up with multiplication that looks like this. All right, taking a look at this one. Oh, wait, hold on. Before you move on, very, very important. I almost made the mistake. Make sure you are including your GCF, right? Your GCF is 3, so you want to make sure you're adding that back at the end, right? You factor it out to start to make this process easier. Make sure to throw it back in at the end. Moving on here, let's look for GCF. Well, we see 3x squared plus 2x minus 16. I don't see any numbers that all of those have in common besides 1, so you can't always factor out a GCF. In this case, we wouldn't. And so we would start by labeling our coefficients. A, B, C. A would be 3, B would be 2, C would be negative 16. We'd make our magic X. On the top, we would want A times C. We would put negative 48. On the bottom, we would put B. And so now we're looking for two numbers that multiply to negative 48 and add to 2. I'm going to say that that will be negative 6 and 8. And then we're going to write this, right? Rewrite the original expression, splitting up our b term into 3x minus 6x and plus 8x minus 16. And so, just so that you can see, this 2 got split up into negative 6x plus 8x, right? Because those two combine back to get us 2x. Okay. Now we want to put parentheses around the first two terms, parentheses around the second two terms, and factor out the greatest common factor from both. So it'd be 3x times x minus 2 plus 8 times x minus 2. And if you did it right, these two parentheses should always match, which then means we can finally just put what we have in front of each of them together in a parentheses, and then leave the parentheses that match. Right, so the 3x plus 8 become their own parentheses, and the x minus 2 become the other half. All right, so here I'm going to start with the GCF. What's my GCF between 64 and 8? Well, it is 4. So let's divide out that 4 first before we start the process of undoing that double distribution. We want to do that on the simplest expression possible. So divide by 4, divide by 4, divide by 4. We're going to get 15x squared plus x minus 2. And we're going to label our coefficients A, B, C. Going to be 15, 1, and negative 2. We want to make our magic X. A times C goes on the top, so it's negative 30. B goes on the bottom, that's 1. We want to find two numbers that multiply to negative 30, add to 1. It's going to be 6 and negative 5. And now we're going to write that out. We're going to replace the b terms. We're going to say 15x squared plus 6x plus a negative 5x. Again, plus a negative is the same as subtraction, minus 5. And then 15x squared plus 6x. Oh, then we're going to put our parentheses in, right? We want to separate it there and there. Here you can see why I put a plus minus there. It's because we want to keep the negative in the second set, but we don't want to lose track of the fact that we're doing addition between those two terms. So that's why I put a plus minus whenever I have a negative to start the second parenthesis. I recommend that you guys do the same so you don't get confused. All right, what's our common factor between 15x squared and 6x? That would be 3x. And what would need to go in the parentheses? That'd be 5x plus 2. So that when we distribute back in, we get back to the original. And then what is our greatest common factor between negative 5x and negative 5? Hold on, something is wrong here. Negative 5x, and that should not be a 5. That should be a 2. Right, and what's the greatest common factor in negative 5x minus 2? Well, you don't have any common factors between 5 and 2 besides 1, but you do have the negative. So you can put the negative out in front, and then that would make inside the parentheses 5x plus 2. So when we distribute the negative 1, they both become negative, meaning that our final answer would be 3x minus 1 times 5x plus 2. We need to remember our greatest common factor out in front, which would be 4. So maybe I'll highlight this. The greatest common factor goes there. The 3x minus 1 goes there. And the 5x plus 2 goes there. Just so you can keep track of where each of those components is coming from. Let's look for GCF for number 4. If we have 16, 24, and 8, our GCF is going to be 8. So I'm going to divide each of these by 8. Divide by 8, divide by 8, divide by 8. And get 2x squared minus 3x plus 1. You want to label our coefficients. A, B, C. A would be 2, B would be negative 3, C would be 1. And then we'll make our magic X. So you want two numbers that multiply to 2, add to negative 3. We see it multiplying to 2. Well, we only have two options, basically. We have 2 and 1, or we have negative 2 and negative 1, or they're vice versa. But like, we're gonna have 2, we're gonna have a 1, and they need to either both be positive or both be negative. Because they need to add to a negative, we know that they're both going to be negative, so we're going to have negative 2 minus 1, which means that I can rewrite this 2x squared minus 2x plus a negative 1x plus 1. Again, keeping track of these two, add to that. And the reason why I put a plus negative there is so that we can put parentheses around this and keep track of our negative signs and also keep track of the fact that we're adding. 2x squared minus 2x, well, that's 2x times x minus 1. And then here, always, always, always make sure that your x in your second parentheses, make sure that what you leave inside the parentheses is positive, which means if there is a negative in front of it, you want to take that negative out in front. So you want to do the negative 1 times x, right? Make sure that what is in parentheses is positive and move the negative outside. Now, importantly, we need to adjust the sign of the second term to make sure that it multiplies back to what we want. So if we want this to multiply back to positive 1 and we have a negative 1, that means that we need a negative 1 inside the parentheses. We want a negative 1 inside the parentheses, so that when we multiply by the negative 1 outside, we get back to the positive. And then we just want to combine our terms in the way that we have been. And we know that we did this correctly, or at least we're pretty sure we did this correctly, because this matches with this, right? If you're doing this and you get different numbers here and here, different terms, then you made a mistake somewhere. x minus 1, and we need to not forget about our greatest common factor. All right, here, GCF between 20, 55, and 30 is 5. If we do 20x squared plus 55x plus 30, and we divide each of them by 5, we're going to get 4x squared plus 11x plus 6. And that's going to be the expression we're going to be working with. And we're going to do A, B, and C, label our coefficients. 4, 11, and 6 make our magic x. Do that up here. A times C is 24. B is 11, so we're looking for two terms that multiply to 24. Add to 11. I think 8 and 3 will do the trick just fine. And then we're going to rewrite this 4x squared plus 8x plus 3x plus 6. Remember, 11, that's not what I wanted to do. Remember, this 11x became 8x plus 3x. Put parentheses there, put parentheses there. We get 4x times x plus 2. I give us back 4x squared plus 8x plus 3 times x plus 2. And then 4x plus 3 times x plus 2, combining what we have here and here to get that. And just don't forget about your GCF 5. All right, GCF here. You got 10, 32, and 24. Ooh, you might think you can do more than 2. You might be like, well, like those all look like even numbers. Maybe we can do 4, but 4 doesn't go into 10. Maybe we could do 8, but 8 doesn't go into 10. So you really can't do anything more than 2. We can do 10x squared minus 32x plus 24. Divide by 2, divide by 2, divide by 2. We have 5x squared minus 16x plus 12. And then we want to label our coefficients, A, B, C. That's going to be 5, negative 16, and 12. Make our magic x. On the top, we're going to put 60. On the bottom, we're going to put negative 16. So we want two numbers that multiply to 60, add to negative 16. I'm going to go with negative 10 and negative 6. I'm going to write this 5x squared minus 10x plus a plus negative 6x plus 12. Put parentheses there and there. 5x squared minus 10x. That's 5x times x minus 2. And again, you want to really make sure you always pull the negative out here, right? You never want this x in the second parentheses to be negative. So we need to pull out a negative 6 times x. And then what do we need the second term to be to multiply back to positive 12? We need that to be minus 2, right? So that when we do negative 2 times negative 6, we get back to positive 12. And now we can see that we have done that right because we have x minus 2 in both of them. And so then we're going to do 2 times 5x minus 6 times x minus 2. Okay. Now looking at some SAT questions. We have 2x squared plus ax is equal to x times 2x plus 7x. For some constant a, what is the value of a? Well, looking at this, we can simplify this by just distributing. So it'd be 2x squared plus 7x when we distribute. And if you'll notice, 2x squared is equivalent to 2x, or 2x squared plus ax is equal to 2x squared plus 7x for some number a. Well, if a is 7, then they're the exact same expression. Right, there's a lot of SAT questions that look like this. Essentially, do something like this, so that it is the same form as this, and then you can just figure out the value of the missing variable by comparing the two. The given expression is rewritten in the form 2x minus 3 times x plus k, where k is the same value. Again, do something with this so that it looks in this form. Find the value of k by comparing. In this case, it's saying factor this. So that's what we have been doing. I'm going to look for a GCF there between 2, 5, and negative 12. I don't see a GCF, so we can't make this any simpler, which means we're going to jump right into our coefficients, A, B, C, which is 2, 5, negative 12. And we want to make our magic X. We want to find two numbers that multiply to negative 24, add to 5, and that is going to be taking a look at it. I'm going to call that 8 and negative 3, which means we can rewrite this 2x squared plus 8x plus negative 3x plus negative 3x minus 12. Put parentheses there, put parentheses there, put parentheses there, put parentheses there. It's the greatest common factor between 2x squared and 8x. It's 2x times x plus 4 minus 3x times x plus 4. And the greatest common factor between negative 3x and negative 12 is negative 3. And there should not be an x there. Hopefully you guys caught that before I did. 3x minus 4. X plus 4, sorry, because negative 3 times positive 4 is negative 12, which means this is 2x minus 3 times x plus 4. So if this equation is equal to this, and it's also equal to this, what's the number we're missing? Well, it's the 4 at the end. So k must be equal to 4. There we go.